Two quick visuals before we start the video. The left visual is the Google Maps layout for the distance test that we ran. The top dot is Dimple Hill where Suyun was, and the bottom dot is the parking structure next to Research Stadium. The picture on the right is a Google Earth visualization of Dimple Hill from the parking garage. Alright, here we are on the parking garage, Oregon State University. We're running our 4-mile test. Suyun is back there in the background on Dimple Hill. Alright, here we are on the parking garage, Oregon State University. We're running our 4-mile test. Suyun is back there in the background on Dimple Hill. That marks the 4-mile marker. So we've discovered his node remotely, and now we're going to go ahead and run a remote range test. And you can see we have an attenuation of about negative 76 decibels, and we're receiving 100% of the packets that we're sending. 11 out of 11, 12 out of 12. 100% of the packets sent are received at a distance of 4 miles. So lastly, we can analyze some of the data that we pulled in. You'll see that the independent variable is time, and the dependent variables are pinned on two axes, the left and the right. The left axis represents the RSSI, the remote signal strength indicator, and the right axis indicates the success percentage. So you can see the blue curve at the top starts out at 100%. It's taking in all the packets that it's sending. This is when I was pointing the directional antenna right at Suyun. You can also see below there are the local and remote RSSI. Those are sort of the squiggly lines sort of going around all the way. So I put the transmitter down, and then about 10 seconds later after talking to Suyun on the phone, I pick it back up, and you can see those red and green squiggly lines moving back up again. And what you'll notice is that the blue line has a positive derivative. So whenever we're receiving as many packets as we're sending, we have a positive derivative. And you see that exponential decrease when I put down the transmitter.